Okay, how you doing? One of the most common questions I get is how to use a graphing calculator. I will quickly go over a few things. I can make more videos if you need to, but if you're taking Algebra 1, Geometry, Algebra 2, FST, and on up, you use it tons. SATs, does a lot of different things. Okay, so I'll try to do this so you can see it. One of the first things, just to start off from the beginning, you can definitely do fractions on it. It doesn't have an ABC key, but the easiest way is to use parentheses. And if you want to put in like a 5/7, push in 5 divided by 7. Let's say I'm going to add to it a terrible one like 85 17ths. When you hit enter, it's automatically going to give you a decimal. Okay, you see that? But if you hit math, enter, it reduces your fraction for you. Sometimes it still comes up to the decimal, but most always it works out like that. Okay. Another quick thing, if you want to do something like -3 to the 5th power, I would use parentheses. On your graph, for the negative key and the subtraction key are different things. Okay. So if I forgot what I said now, but if I did -2, okay, raised to the 5th power, you with me? In the parentheses, and there you go. Does that make sense? If I wanted to do -3 59ths, ready, raised to the -1/3 power, same deal, right? Boom, there you go. I don't think that'll give me a fraction, but maybe. Nope, that was a bad one. Okay, so let's say we want to do something like this. Let's say I wanted the 15th root of 9. Okay, the 15th root of 9. What I'm going to do is take 9, and I'm going to raise it to the 1 divided by 15 power. Okay? And that's going to be the 15th root of 9. And there you go. That's how it works. Okay? So let's see a couple things. One of the most common things people ask is, how does it graph? Well, you go into your y equals. Okay? Y equals. Now I had something there already, 2x plus 4, and I'm going to delete that. So I hit clear. You want to make sure your plots are off. See these up here? Those mess up your graphing for right now, so we want to have them off. Let's say one was highlighted, okay? You're going to go up to it, you're going to hit enter, and turn it off and go back down. Now it's going to graph just fine, okay? So here's an example. What if I wanted to do 2/3? I'm going to use parentheses for right now. You don't always have to, but it's better to get used to it. 2/3 x plus 6. Now, if you remember rise over run, you're very familiar with that form, but you're going to graph it. Hit graph. Okay. Now that doesn't look very nice. One trick that helps a lot usually is you press the zoom and 6, and that gives you a standard 10 by 10 viewing window. Okay. And that's that. There you go. Let's say I wanted to identify my x-intercept. Okay. X-intercept where it hits the x-axis. The first thing I would do is try to change my window settings. Right now, it's set just to -10. I can't see it very well. But if I hit window and I change my x-min to say, I don't know, -30. Let's try that again. And then I hit graph. It changes my viewing window. Okay? If I wanted to find out where that hits the x-axis, I go to, that would be a 0 technically, right? I'm going to hit second, calculate, and I want a 0. Okay? Hit enter. And it's going to say left bound. Well, it's going to be the left-hand side of that intersection point where that 0 occurred. So right now it set me up pretty good. I'm going to hit enter. Now it says right bound. So I'm going to go over here. Okay? And I said guess, and I don't have to guess. I get a calculator. So I hit enter. And it tells me -9 is my x-intercept. Okay? That's kind of a way to manually find it. Sometimes you can be a little more direct if you know whereabouts. If I were to say second calculate again, I want my 0. Left bound, maybe I'll just say, well, I know it's between -12 and I know it's between, I don't know, -5. If I hit enter and guess, it'll still find my 0 at -9. Okay? This also works for quadratics. Let's say we wanted to graph a parabola. Okay? Let's just do a basic one. Let's say we have a 2x squared plus 6x, I don't know, let's say minus 8. Okay? When I hit graph, that's still thinking. That's not a bad picture. I think we can make it better. So I'm going to go to zoom 6. Okay, and right now I'm looking at it and I think, well, it looks good, but if I could see the vertex or the minimum point, I could do a lot more math with it, right? So I'm going to go to window settings, and what I'm going to change is my Y min. Well, I'm going to change that maybe to negative 25 and see what that gives us. Okay. Okay, that was perfect. So a couple things I could find here. If I wanted my roots, I can do that in a minute. Right now I'm going to find my vertex, which in this case would be my minimum value. Okay. So I'm going to go to second, calculate. Now if I want my minimum, hit enter, it's going to say left bound. I call it a little spider. Right there, we're going to move that with the cursor keys to be slightly left. Hit enter. Now it says right bound. I want to go slightly to the right of that lowest part. Hit enter. It always says guess, and you say, and there you go. That's your vertex. Negative 1.5 and then negative 12.5. And if you look at it, it seems reasonable, and it makes perfect sense. Okay? If I want to find my roots or my zeros or my x-intercepts, all kind of synonyms, right? I'm going to push zoom 6 again just to get a little better viewing window. I found my vertex. Zoom 6. Okay? So I don't care about the vertex now. Now if I want to see that a little better, I can even kind of cut off my left and my right. So if I go to window and I say, well, my x min, let's say if I just want to go to negative 7. Let's say my x max, maybe I want to go to 5. Okay, so it just kind of makes it a little more clear for me. Okay, so when I want my roots, my zeros, I hit second, calculate, and I want a 0. Well, when I plug in that, it's going to say left bound. Now I don't see my little spider creature here, so the little hint is down here with our Y menu. That negative 12, I know that's where my cursor is, so I'm going to go as close as I can to get back up to 0 so I can see it. And there we go. So it says left bound. I think you can see that, right? So I want to be right on the left-hand side of that intersection. So I'm going to hit enter. Right bound, I'm going to be on the right-hand side of that intersection. Boom. Guess? Nope. There we go. So negative 4 is one of my zeros. When I want the other one, just start again. Second, calculate. I want a 0. Hit enter. And I'm going to take that little spider creature. I know where I'm going. It's going to come back up in about 2 seconds. Well, I guess it's 3 seconds. There we go. So it says left bound. I'm on the left-hand side of that intersection point. Hit enter. Now I'm on the right-hand side of that intersection point. Bang, bang, done. So my other 0 was at 1. Okay? Now, there are a lot of different types of problems where you might need to know some values specifically. Another option you have is to go to second, calculate, and value. Well, what if I want to know where that parabola hits when x is, say, 20, where that hits? Well, if I hit value and I hit 20, it's going to say error. And I say, oh no, I made a mistake. But you did not. It's going to say go to, and you want to know why. And it's going to say, hey, look, num num, you only had that y max up to like 5 or 6, and you want to know 20. So you're going to go to window. You're going to adjust your x max, let's say to 25, okay? You really only have to go to 20, and graph it again. Okay? Now when I say second, calculate, value, and I plug in 5, or I forgot what I said, did I say 20 before? When I hit 20 now, and I hit enter, it gives me 912. Now you don't need to see that ordered pair, you just know that when x, right there, is 20, the new value or your output or your dependent variable would be 912. Okay? That's not that bad. You're going to use that type of function often. Okay? So let's see. You know how to do fractions, exponents. You know how to graph. You know how to find your roots, intercepts, minimum. Clearly you see a y-intercept was negative 8. You don't need calculator to get that. How about matrices? That's a common thing. A couple tricks you can do with them. Let's try to find... Okay, where we go. So yellow matrix, second matrix. Now, right now this is a 2 by 2. Okay, so let's just edit it. And we're going to make it a 3 by 3 just so we can show you how to do it. Let's say it's a 3 by 3. Okay, let's just make an easy one. 1, 2, 3. let's say 4, 5, 6, and let's say 1, 2, 7. Okay, nothing to do with it. A couple things we can do with it. If I wanted to find the determinant, I'm going to go to second matrix. I'm going to go to math. DET stands for determinant. So I'm going to hit determinant. Oh, sorry, I didn't mean to go there. I'm going to go to second quit, and now I'm going to do it. So second matrix, math, determinant. Now I go to second matrix again, and I'm going to plug in A. Okay? So if I hit enter, it's going to give me the determinant of matrix A. And done, negative 12. Okay? That's not too hard. Now if I want to go to second matrix again, maybe I want to take B, and I want to do something with it. Maybe I want to make that a 3 by 3. So I can make that a 3. Already was, I guess. 3. Let's just call it a 1, a 2, a 3. Nothing exciting. A 4, a 5, a 6. And maybe a 9, a 9, and a 9. Now, a lot of times you have to multiply or add these things. It gets kind of tedious, albeit fun. So I'm going to go to second matrix again, and I see that my A and B are done. Well, when I go to second quit, clear that out to my computation screen. If I want to multiply these two together, I'd go to second matrix, A, times, or plus, or divide, whatever you would, not divide, but add, subtract, second matrix, B. There are little shortcuts here and there too, and then enter. And there you go. Does that make sense? Now, probably what you were all waiting for is Cramer's rule. If you have a three variable system, like an X, Y, Z, okay, one of the ways they show you how to do it is elimination. Another one would be Cramer's rule, which again is great but very tedious. You can use inverse matrices to solve it really quickly. Okay, so just bear with me for a second. I'm going to go back to matrix. Now, I'm going to use my math here. We'll just explain it. Let's say that those were the leading coefficients of all the different variables. Okay, let's say that was a 1x, and let's say that was a 4y, and let's say that's a 1z. Okay, and let's say that was a 2x and a 5y and a 2z. You get the idea? So you take the coefficients of all your terms. You label them like that. That makes sense? Now, let's say we had the answers. I'm sorry, what they were equal to. Okay, so I'm going to go back to second matrix. I'm going to go to edit, and I'm going to make this one a 3 by 1. Okay, let's say 1, 2, and 3. That's as easy as anything. Okay, so now we go back and we quit. Now I'm going to take matrix A. Okay, I'm going to find the inverse of that. So if I hit right there, that's my inverse key. And now I'm going to multiply it by matrix B. Second matrix B. We're done. 1, 0, 0 would be your solutions. 1 would be X, 0 would be Y, and 0 would be Z. And that is it. It kind of takes all the work out of it. Okay? So those are a couple things. I will post one in a little bit on stats, but that is good for your basic Algebra 1, Algebra 2 use with the TI83 graphing calculator. 84, same deal. Okay? Good job.